Greetings, chemistry fans. So what I have for you here is not a particular homework example, but me naming a few compounds. And I have a periodic table here, so we can refer to it, and it will allow us the chance to, well, name some compounds with a periodic table at our disposal. So the first thing I'm going to do is I'm going to write one out. And suppose I ask us, we want to do something like, I don't know, strontium nitride. And you should have a periodic table at your disposal. And you should take a look at it. And you might remember I had you write a, well, +1 here, a +2 here. We skip the middle here, and we write a 3 plus here. We skip this one, and we go on to 3 negative, 2 negative, and 1 negative. And this just gives you an idea of what the charges of everything in those columns must be. Now, we find strontium, and I find it down here. Let me highlight this. And you'll find, well, hey, here's my strontium, and here's my nitrogen. And so knowing strontium and nitrogen are where they are, that'll allow me to decide what their charge is. For instance, strontium, if it's in that column, has a +2, and nitrogen has a -3. And you'll find that they both end up going into 6 evenly, and therefore we have an empirical formula of SR3N2. Well, it's a beautiful thing, isn't it? Next, let's do another one. So suppose we come up with something like, I don't know, copper 2 bromide. Now, the fact that there's a Roman numeral there is because copper is a transition element. So when we find copper on here, and I might as well highlight it again, we find copper here, right? And copper is right there. However, bromine's here. Bromine is a predictable charge because it's in the -1 column. Copper has a Roman numeral because it doesn't fall in one of our predictable columns, but it has a Roman numeral which indicates its charge. And so we know that copper must have, well, a +2, and bromine has a -1. We both go into 2 evenly, and then you have CuBr2. Pretty excellent, huh? Let's try another. Where in this case, let's do one with a polyatomic ion. And so now polyatomic ions, well, they have different endings than IDE. So let's suppose we did something like aluminum, and it can be aluminum, say, no, nitrite. Now it has this ITE ending, nitrite, which tells us that it's polyatomic because it's not IDE, and very few polyatomic ions have an IDE ending. And so what I'm going to do is look up aluminum off the periodic table, and I'd find aluminum's part of the group that has +3 charge. Now you can't look up nitrate on the periodic table. You've got to look into your memory banks, or on a piece of paper that has NO2 with a -1 charge. The way it looks, as well as the charge, are tremendously important because you need to now figure out what they both divide into evenly, which is 3. And we have 1 aluminum, but to show that we have 3 nitrites, we have to put it in parentheses and write a 3 on the outside. 3 compounds named just for you.